The second georeferencing method that I want to share with you is the kind of scenario where you have a small scale map in either vector or raster format, and so you can't really use the MAPublisher georeferencer because it's going to be very hard to accurately identify those world locations that you see on your map. And any small mistake that you make there is going to have a lot of effect in the overall accuracy. And so there's often cases where you have a reference map and you have a pretty good idea, you've got a pretty good educated guess about what projection and what scale or what scale it's supposed to be in. So in this case, this is for a project that I've done a couple of years ago where I had to make a small map of Algeria and some stuff happening in Algeria in the early 1950s. Now, in the early 1950s, the northern part of Morocco was Spanish territory, and I wanted to show that boundary. I didn't have any GIS data showing that boundary, but I did find this one, this I believe 1950 map in the David Ramsey map collection. It's originally from the Times Atlas, which is showing the boundary of Spanish Morocco. Now, this is not terribly accurate, but it doesn't have to be for a small map. So if we can sort of get most of this boundary correct, I'm going to be pretty happy. Now, unfortunately, this isn't a perfect scan. You can see if I've used a ruler here, you can see that the top of the page is sort of kind of wavy. So it's not a perfect scan. And also it doesn't actually say which projection it is. I mean, judging by the way the meridians curve, I'm assuming it's a conic projection, but it doesn't actually specify which one it is. Now, this is where the educated guess comes in. I have a pretty good collection of atlases, including a couple of Times atlases. Not from 1950, but I do have one from 1968, which, by the looks of it, is, at least for the top part of the map, is the same projection. In fact, I may even have used the same place for it. And this one does actually say which projection it is. It's the Lambert-Zenithal equal area projection. Now Zenithal was used as a sort of alternative term for Azimuthal. So this is our educated guess. Now, since I'm only going to be interested in this little part of the map, I'm going to crop this out. And save it. And I've already set up an illustrated document with the 10 million natural earth coastlines for this area. And so the process that I'm going to go through is I kind of know which projection it's supposed to be. So I set up a map view with that projection, with that scale that I'm assuming it's going to be. And then I'm going to place in my raster image and basically just tweak the map view as long as I need in order to make it fit. Now, the thing with conical projections is that there's usually two parameters involved. There's a central meridian and there's one or sometimes two latitudes of origin. I don't actually know which ones it's going to be. Now, if I go back to the original image here, I'll just undo this. The central meridian is usually pretty easy to identify because it's the meridian that's pointing straight up. It doesn't actually appear to be on this map. So you can see the meridians sort of curving towards top right. And the further we go to the right on the page, the straighter they get, but they're not exactly north-south yet. So this is 10 degrees. You can see there's still a little bit of an offset. So I'm not exactly sure what the center meridian of the projection here is going to be. But I'm going to go ahead and change my map view here. And I'm going to, let's see, Azimuthal equal area. I'm going to make a copy of this. I'm going to change its definition. And I'm going to assume that the central meridian is going to be 11. Might be 11 and a quarter, because that would be the Florence meridian. Let's try 11. And I'm really not sure about the latitude of origin, to be honest. So we'll do this and we'll see what happens. And the scale of my map is, my original map is 1 to 5 million, so I'm going to plug that in. And then on layer 1 I'll place the image I just created. So now it's a matter of either moving the image or changing the map view until they line up. So first I'm going to get the image roughly to the right location. And we're getting there. So this is already pretty darn close. What I usually do if I edit the map view, it's going to be stuff like scaling, maybe rotating it a little bit or changing the parameters of the projection. I make this window a bit larger and I zoom in. And I set thumbnails for both layers. Zoom in. And again, this isn't an exact science, so I don't know whether I've got the right settings for this projection. I don't know how accurate the original map was, but looking at the coastline, I can tell we're getting pretty close. It doesn't actually want to zoom in more than this. I can tell we're getting pretty close. And given the fact that I only really need to digitize this boundary, I'm actually pretty tempted to maybe say that this is it. It's not perfect, and you can keep on tweaking this for sometimes even hours on end. But knowing that this is going to go on a map that's probably 4 by 3 inches, I think this is pretty good. So from here we can add another layer, we can trace over this line, export that layer to a shapefile, and it's done. Here's a second attempt at the second method of georeferencing. For another project, we needed to include the extent of the Bering Land Bridge on a map of the Arctic region. We were given this image as a reference, and well, it kind of looks like it's a polar projection. So we tried to georeference it. I set up an illustrated document with, in this case, the natural Earth 50 million scale coastline and Arctic Circle. And I'm gonna see if I can find a good projection to use for this. So there's a couple of different polar projections in the standard library. I've tried this out before, of course, and it looks like this one, the polar azimuthal equidistant, is a pretty close match. So I'll use that one. And I'll just place a reference image on layer 1. And just scale it to something a little bit more useful. Shouldn't move stuff on those layers, of course. So the first thing that you notice is that there's a pretty big rotation factor. But we'll go play with the MapView editor and see what we can come up with. So I think let's first look at the rotation. It should be minus 90 to get somewhere close. Yeah, so here's Kamchatka in probably the image, and here it is in my vector data, so we're close. And next one is the scale. So I want to make sure that the Arctic Circle kind of lines up. And you know what, that's already looking pretty darn close, to be honest. So we're obviously only interested in this bit down here. So if it doesn't line up on the other half of the map, that's not really an issue. And in fact, the map that we're supposed to be producing kind of stops at about halfway through Siberia here. So this part isn't terribly important. So let's zoom in a bit and see if we can improve on this. So I'm looking at the coastlines, making sure that they line up. Or at least try and get them as close as possible. And this is a process that can go on for quite a long time, actually. Just tweaking it and shuffling and moving it. Sometimes if I can't manage it, I just basically start all over again. I think, to be honest, I'm most happy with how this is looking. So from here it would be a matter of tracing those lines, adding them to the map view, and exporting them to a shapefile so we can include them on our actual map.